Hi, warm welcome on Jaman's MATLAB coding. In this episode, we'd like to discuss how one can determine the stability of a control system from amplitude response. A control system is unstable if the amplitude increases with time. That decision we can take by visual inspection of the output graph. So for that, we need to grab the output response first. The next question is what the amplitude can be. Well, the amplitude actually can be any physical quantities. It depends on the control system we are working on. For example, the amplitude can be displacement, can be speed, can be temperature, can be force, etc. Viewer needs the background of clip 42 where we discussed how to find the equivalent of a control system when it is given in block diagram form. On the screen, you find the block diagram of clip 42 which needs the transfer functions g1 equals 1 by s square plus s plus 2, g2 equals 0.5, h equals 1 by 3s plus 2. Here, our input is ut, the standard Heaviside function. We would like to find the equivalent function. An equivalent function, how do we find? It is the repetition of clip 42 commands with different transfer functions. So the workspace variable E keeps the equivalent transfer function for the whole block diagram. Viewer needs the background of clip 38 where we discussed how to find the step response of a control system in MATLAB. Well, here our input is ut, which is very much like the graph shown on the screen. We know that equivalent transfer function y to r is available in the workspace variable e. We would like to test the amplitude response over two intervals 0 to 10 seconds and 0 to 100 seconds. So go to MATLAB command prompt, call step e comma 10 for the first interval, then call step e comma 100 for the second interval, and you're gonna see the response as shown on the screen. Let us analyze the two responses. In the first response, we see the output is showing some sort of oscillations, but the oscillation slowly decreasing and heading towards some steady state. But we are not sure, that's why we had to increase the interval from 10 to 100. With increased interval, we find that the oscillations died out and the output heading towards steady state value. Now for unity step function input, the output should also be similar to ut or Heaviside function as far as linearity is concerned. And we also assume that the system is linear. So the trend of the second response is similar to input. And we can say that since output is not increasing, it is similar to input, so the system is stable. In order to view the unstable amplitude response, let us change the g of s, which is 1 upon s square minus s plus 2. Only the change of sign of s coefficient. Therefore, you need to modify the previous MATLAB statements, which are G1, G12E, as you see on the screen. Let us explore the response over two intervals from 0 to 10 seconds and 0 to 50 seconds. You might ask, how do I decide the interval? Well, that is basically by trial and error. So run the commands in MATLAB. On the screen, you see the two responses. On the left side, you have the response for 0 to 10 seconds, and on the right side, you have the response for 0 to 50 seconds. The left side response, as you see, the amplitude is increasing, but from 0 to 50 seconds, the amplitude increase is drastically very high. You see the amplitude range, which is in the range of 10 to the power 11. So what can we say from this behavior? Well, the input is ut, output should be very close or similar to ut. There is no such source which will give us constantly increasing output for a finite input. So for sure, this kind of amplitude response is unstable. All right, no more today. Don't forget to share, like, and subscribe our contents. Your engagement gives us big encouragement. So please do it. I hope to see you in next clip. Bye for today and stay safe.